Welcome to The Explainer. Today, we're taking you behind the scenes, to the front lines of an invisible war, a battle that developers are fighting every single day just to make the apps on your phone run perfectly.
You know this feeling, right? We've all been there. That moment an app just stops. An animation freezes mid-swipe, or scrolling just becomes this choppy, frustrating nightmare. But what is really going on when that happens?
Well, I can tell you it's not just some random glitch, it's actually a symptom. It's the result of that invisible war being waged right there inside your phone for its limited resources.
So today, we're going to explore the strategies, the tactics, and even the weapons that developers use on the front lines of this fight for performance, all in the name of giving you that seamless, buttery smooth experience you expect.
Okay, first things first. Let's properly identify the enemy. We're talking about the dreaded lag, the annoying stutter, and of course the catastrophic crash. These are really just the outward signs of a much deeper conflict.
A huge part of this war is fought over your device's memory. And right on this battlefield, developers have to make a choice between two totally different strategies. On one side, you've got manual control. This is where the developer is in complete command of every little piece of memory. It's super fast, super efficient. But on the other side, you have automatic cleanup. This relies on something called a garbage collector. Think of it like a robot butler who, completely without warning, decides to stop everything to tidy up. Sure, it's convenient, but it can freeze your app at the worst possible moment, and that's what causes those infamous stutters.
Now, the biggest danger with that first approach, the manual control, is something called a memory leak. You can think of it like a slow, silent act of sabotage. The app keeps asking for memory, but then forgets to give it back. Bit by bit, it drains all the available resources until the whole phone slows down or the app just crashes.
The good news is developers are not fighting blind here. They have a whole arsenal of specialized tools to hunt down these leaks. Tools like FastMM or Deleaker act like crime scene investigators for your code. They can pinpoint the exact moment a resource was taken out but never returned, letting developers plug that leak long before it ever affects you.
But this war isn't just about managing memory. It also gets fought down in the trenches, in the code itself, where every single decision, every line, is a critical trade-off.
Here's a classic choice developers have to make: how to compile their code. Do they tell the compiler, hey, make this thing run as fast as humanly possible, which, by the way, usually makes the app file bigger? Or do they say, make the app as small as you can, which might mean giving up a little bit of performance?
And just how big of a difference does that make? Well, get this. The Skia graphics library, it's a core piece of Android, when it was built for development, was a massive 50 megabytes.
So why was it so huge? Because the build included all this extra debugging information. Now that stuff is absolutely essential for developers while they're working, but for you, the user, it's just dead weight. It's totally unnecessary data that makes the app bigger and slower to download.
But by simply flipping a switch, literally telling the compiler to strip out all that extra info, the developer shrank the exact same library down to just 5.5 megabytes. That is a nearly 90% reduction in size from one simple command.
All right, so when it's all said and done, the most critical mission in this entire war is protecting the user interface. You can think of the UI as the civilian population. Its safety, its happiness, that is the #1 priority. And that defense all centers on something called the UI thread. Think of it like the only cashier open at a really busy supermarket. It's the single lane for everything you see and do in an app. If a developer tries to send a slow, heavy task down that lane, like loading a huge file, all traffic just stops. The entire app freezes.
So to prevent that kind of disaster, developers live by two sacred rules. Rule number 1, you do not block the UI thread, ever. And rule number 2, you do not try to change what's on the screen from anywhere else. It's just not safe.
And this right here perfectly shows the tactics they use to follow those rules. A command called synchronize is like trying to merge into heavy traffic on the left. The background task has to stop and wait in line, creating a potential traffic jam. But a much smarter command, queue, that's like an express lane on the right. The task just drops off its message for the UI and immediately gets back to its own work, keeping everything flowing nice and smooth.
So after all of these different battles, over memory, over code size, over the user interface, we get to what is maybe the most important takeaway from this whole invisible war.
The thing is, this isn't a fight that's ever truly won.
It's a constant, continuous process of vigilance. As our phones get faster and apps get more and more complex, developers have to constantly reevaluate their choices, always trying to find that perfect balance between speed, size, and features.
And that's the real victory, isn't it? The very definition of a buttery smooth app is when you, the user, have absolutely no idea that this intense, constant, and complicated battle is even happening behind your screen.
So, something to think about until our next explainer. The next time you're just effortlessly scrolling through an app, maybe I'll take a second to think about the invisible victory that made it all possible.